Now let's continue to revision 2, still on vectors and integral, but still again on vectors. So we are now going to see the dot and the vector products questions. Now we start with question 1. Question 1 talks about vector P. So let me just bold it, and vector R. Then we are asked to get the area of the parallelogram form for which the vectors P and R are adjacent sides. So by definition, we know that. So first let us get our vectors. So P vector in column form, simply 2, 3, -1, okay. And R vector in column form is simply 1, -2, and 3, okay. Now we have a condition that the magnitude of P vector cross R is equals to the area of the parallelogram formed by the two vectors as adjacent side. So we need to get the magnitude of the cross product. So first we need to get the cross product of P and R, which is simply equals to the determinant of the matrix formed by the vectors. So which matrix is it? Here it is. Now we have I, we have J, and we have K. Now P as a row will be 2, 3, -1, and R will be 1 and -2, 3. So we want to perform the cross product and get the magnitude of the cross product of the two vectors, which will give us the area of that parallelogram. So that is the definition. Okay. Now before we go to the cross product, we need some definition on Cartesian coordinate system. Now we know that the cross product of two vectors is a third vector perpendicular to the two vectors. Now let's see what is happening, and direction matters. So the first case we have I. For us to get I, we cross J to K. So when I cross J to K, the direction is anticlockwise. The third vector that is perpendicular to K and J is I. And it is positive because the direction is anticlockwise. I think we remember that. Anticlockwise direction, positive. For physicists, I think you need to remember that. Now, for J, here we need to cross I to K for us to get J. Now I to K, so look at our direction. The direction is clockwise. Now when you cross I to J, you get a third vector J, which is perpendicular to I and K. Now since it is clockwise, the answer is J, but it's negative. Now the last vector is K. You need to cross from I to J. When you cross from I to J, the third vector that is perpendicular to I and J is K. And when you look here, the direction is anticlockwise, so it is positive. So the three matrices that we are going to get from this are the following. We'll get the matrix for I, then minus. Why are we putting minus? Because the matrix for J is negative. Now the negative is here, negative J. Then K is positive, so we have a plus here. Then the matrix for K, which we have here. I hope we are together. So we have a negative here, which you should always remember. We have a negative and then a positive. The negative is that J, which is the X, the Y, is always negative because the direction is clockwise from here. Now, how do you get the matrix? When you want I, you ignore I. Now, when you ignore I, the matrix that remain is 3, -1, and then the matrix that remain is 3, -1, and then -2, and 3. You can see 3, -1, -2, 3 for I. Now, if you want J, U close J. When you do that, the matrix remaining is 2, -1, and then 1, 3. Of course, that is what we have, 2, -1, and then 1, 3. Now finally, we want K. Now if we want K, the matrix we have for K is 2, 3, 1, and -2. Now we need to get the determinant. The determinant of this matrix is product of the main diagonal minus the other diagonal. The arrow point the product of the main diagonal, while the one without arrow is the product of the other diagonal. So what do we have? We are going to have 3 times 3 is 9 minus -2 times -1 is 2. So let me just put these brackets first. So we'll have that minus, we got the determinant of the other one, J, then plus the determinant of the other one, then K. I can fill the brackets. Now for J, we have 2 times 3 is 6, minus 1, -1 times 1. Then for K, 2 times 2 is 4, then minus 3 times 1 is 3. So when you work this out, here we'll have 7, here we'll have 7 as well, and here we'll have 1 because of 4 minus 3. So what do we have? We have 7i, I forgot to put I here, then minus 6 minus 1 is still 7, but now J, then plus 4 minus 3 is 1, which is just K. So this is the cross product of vector P and vector R. Now, area of the parallelogram form will say is the same as the magnitude of P R cross R, which we now know. Now to get the magnitude, it's just the square root of x squared plus y squared plus z squared. What do we have? Square root x, the value coefficient of x is 7 squared plus -7 squared plus for z we have 1 squared. Now using your calculator, you should have this as so let me use my calculator to solve that. Then okay, so using my calculator, I have 7 squared is 49 plus another 7 squared, 49 plus 1. That gives me 99. So we'll have square root of 99. You can write it, leave it like that if you like, or you can get the square root. So we'll have square root of 99. And close the bracket. Let me see. I have the bracket down. So the square root of 99 is approximately equals to 9.95 square units because it was the area. So it is square units. Okay, we have that. It's done. So mark this. Very important. The area of the parallelogram formed by two vectors as the adjacent sides is given by the cross product of the two vectors, and then you get the magnitude. Now we go to question B. Consider the three vectors. Let me correct this typo. Consider the three vectors given by all this. Determine the value of scalar. Determine the value of scalar alpha for which the vectors u, v, w are coplanar. Very nice. So vectors are coplanar, another important thing. For coplanar vectors, we said the vectors which lies on the same plane mathematically if the determinant of the matrix they form is 0. So when the determinant of the matrix formed by the three vectors is 0, then the vectors are coplanar. They lie on the same plane. Now, for us to get the determinant of the matrix formed by the three vectors, then we need to put them. Now on the first row, we have vector u, which has values 1, and then 2, then -1. On the second row, we have vector v, which has values 2, -1 for j, and 3. On the third row, we have vector w, which has alpha there, then it has 1, and then it has 2. Now I use straight line to show determinant. Now we are going to get a 3 2 by 2 matrix. I hope you remember the way we did with I. This is the same way we do with this. But now our I, J, K are 1, 2, 3. So it means where I is, we have 1, you can see. Now minus, you remember J is negative. Now we have another matrix for J, and where J is, we see 2. Then plus K is positive when you do cross product. Now where K is, we'll have our matrix, and where K is, we have -1. Remember up here. So we have a matrix, I is the first one, J is the second, and K is the third. But remember, J is negative because the direction matters. Now let's pick our matrix as before. We want the matrix for I. We delete that first row and first column. Now the matrix is -1, 3, 1, 2. Okay, let me use blue green so it to look nice. So the matrix is -1, 3, and then 1, 2. Now we do the same. You want J, which is 1. The matrix for J, you delete column 2 because J is in column 2 and also in row 1. That is what you can see. The matrix remaining is 2, 3, alpha, sorry, keep on forgetting. So the matrix remaining is 2, 3, alpha, 2. Correct. Now that is done. Now if you want K, you delete column 3 and row 1 because K is in the position of K is row 1 and column 3. Delete them. You ignore K. Now the matrix that remain there is 2 and -1, and then you have alpha and 1. This is 2, -1, alpha 1. The other one was 2, 3, alpha 2. Then the other one is -1, 3, and then 1, 2. Correct. Now, having done that, we can now get, and remember, this determinant must be equals to 0 because the vectors are coplanar. Therefore, the determinant of the matrix formed by them is 0. Good. So let's do the determinant. So we'll have our 1 here, our minus as usual. Then for J, we'll have 2 here. Then plus for K, we'll have our -1, and the answer must be 0. Now let's see. Product from the main diagonal minus other diagonal, main diagonal, other diagonal, main diagonal, other. So when we do that, what do we get? -1 times 2 is -2 minus 3. Then 2 times 2 is 4 minus 3 alpha. Now 2 times 1 is 2 minus alpha. So when we do our job here, we get -5 times 1 is -5. Then when you do job here, you have -2 into 4 minus 3 alpha. Then plus, we have 2 minus alpha will be -1 into 2 plus alpha. Then this will be 0. So when we expand, we get -5, -2 become -8, then negative, positive, -2 times 3 gets 6 alpha. Then -1 times 2 is -2. Then Negative 1 times positive alpha is negative alpha, and this must be equals to 0 because they are coplanar vectors. They lie on the same plane. Now we proceed. So when we collect like terms here, we have 6 alpha minus alpha. Then we take these ones that are not alpha, that doesn't have alpha, to the other side of the equation. So when you take negative 5, it becomes positive 5. You take negative 8, it becomes positive 8. You take negative 2, it becomes positive 2. You can see negative 5 cross the other side negative, negative 8 cross the other side positive, and negative 2 cross the other side, it is positive. Now, if you look at this, 6 alpha minus alpha is 5 alpha. Now, the other side, we have 10 plus 5 is 15. Now, divide this by 5, divide this by 5. So if the vectors are coplanar, then alpha must be 3 for the product, for the determinant of the matrix formed by the 3 vectors to be 0. So that is how we solve for coplanar vectors. The determinant of the matrix formed by the 3 must be 0. Now we proceed. The next question tells us, if alpha is 4, calculate the volume of the parallel pipe formed by the vectors and acting as adjacent sides. So the volume is simply the scalar triple product of the 3 vectors. So we already know, which is the same as getting their determinants. So getting their determinants when alpha is 4. So let me have the vectors when alpha is 4. So we'll just follow the same procedure very quickly. Now alpha was there in the last column, so we only change this. So 1, 2, negative 1. So we have 1, 2, negative 1. Okay. Then 2, negative 3, 3. 2, negative 1, 3. Then we have 2, negative 1, 3. And then the last column, now we make sure alpha is 4. So 4, 1, 2. So alpha is 4, 1, 2. Now we need to get the 3 matrices. For I is 1 on the top, then minus because j is negative. So j is 2 on our matrix here, then plus k must be positive because we have already shown that, and the value of k is 1. Now, what you should know is that the volume, I think that is something very important. You should know this. The volume is given by the scalar triple product of the 3 vector, that is v, the magnitude. In fact, the scalar triple product gives us a scalar. So it is simply the scalar of u, the scalar triple product of u, v, w vector. So that is what we mean. And performing a scalar triple product is simply the same as finding the determinant of the matrix formed by the 3 vectors. We also have an option. You can do first the cross product and then you do the dot product. It will give you the same thing. So I don't need to go that. You can follow and try that. Now for 1, remember what we did? For 1, our matrix is going to be negative 1. It's going to be a negative 1, 3, 1, 2. Now we know what happened. So I can just move on. For J, you delete its position, which is row 1, column 2. The matrix is 2, 3, 4, 2. Good. We proceed. For K, we delete column 3 and row 1. When that happened, the matrix remaining there is 2, negative 1, and then 4, 1. Now get their determinant. Now we know the first determinant we multiply by I, which is 1. Second determinant we multiply by j, which is 2. And the third determinant we multiply by negative 1, which is k. Now on the determinant we have product of main diagonal negative 1 times 2 is -2 minus 3 times 1. I hope this is now okay with you. Main diagonal minus the other one. Okay, let's proceed. Now 2 times 2 is 4 minus 12, or 4 times 3. Then 2 times 1 is 2 minus 4. So when you do that maths, -2, -3 gives us 5 times 1 is 5. Then we have 4 minus 8 here is -8. 4 minus 12 is -8. Negative times negative give you positive, so plus 8. Then times 2, 16. So 8.2. So that we don't omit it. Now -2, well now 2 minus 4 is simply 6. So 6 times -1 is becoming -6. Now we have 5 plus 16 minus 6. So the volume of that particular parallelepiped formed by the three vectors is 5 plus 6, which is 21, minus 6, and the volume is likely to be 15 cubic unit. So that's again something you should note. The volume found by the three vectors of that particular parallel pipe is given by the scalar triple product, or you can cross the two vectors and then you find the dot product. Same thing. Now the next question is just 1 mark, which tells us, state whether the vector u, v, w are linearly dependent or not if alpha is 4. So if alpha is 4, we also have another definition that for linearly dependent vectors, if there are 3, dependent. For linearly dependent vectors, very important, linearly dependent vectors, if there are 3, then something is here. Then the scalar triple product, which is u, v, okay, let me have it correctly. So the scalar triple product, which is u dot v cross w, must be equals to 0. Or simply say the det of the matrix formed by these three vectors is 0 for linearly dependent vectors. Then just for notes, so that's why I'm writing them, for writing them. So the linearly independent, if the vectors are linearly independent, then the scalar triple product of the three vectors, which is u dot v cross w, is not equals to 0. Simply, or we can say the determinant of the matrix formed by the three vectors is not equals to 0. Now, if alpha is 4, so if alpha is 4, we have already performed the determinant of the scalar triple product. We found that the determinant of the matrix is equals to 15, which is not equals to 0. So we'll say the vectors are linearly independent because their scalar triple product is not equal to 0. So we move on. So the notes are there for you, and we have the answer. Now the last question is on dot products, where you're asked to find the angle between the two dot products, the two vectors. So we know the definition of that. P dot Q is simply equals to the magnitude of P times the magnitude of Q times cos theta, where theta is the angle formed between the two vectors. Now again, we know that the dot product P dot Q is given by the row matrix for vector P, which is given by the coefficients of the P vector, which is P1, P2, P3, times the column matrix formed by Q, Q1, Q2, Q3. Now from our information we are given, the row matrix for P is 2, -1, 3, times the column matrix for Q, which is 1, 4, -2. And this takes place because I dot I is the same as J dot J, which is the same as K dot K, which is equals to 0. Also take a note that I dot J is the same as J dot I, which is the same as K J dot K, which is the same as K dot J, which is equals to K dot I, the same as I dot K, which is equals to 0, because the angle between them is 90 and cos 90 is 0. Now let's move on. So means the dot product is a scalar, so we are not going to have any i's and j's or k's in our result. So how do you get the dot product? The first case is for x, the second case is for y, and the third case is for z. So 2.2, 2.1. Second case, -1.4. Third case, 3.2. So what do we have? The dot product will be 2 minus 4 minus 6. So this will give you negative. So 4, 6, -8. Can confirm. 2 minus 4 is -2. -2 minus 6 is -8. Okay, let me have the right thing, the black one. So we'll have -2 minus 4 minus 6, which is equals to -8. Now we go to our first definition. -8, which is the dot product of these two vectors. Oh, we need to get the magnitude first before we can divide. Okay, so the magnitude of P, we already know, is the square root of x squared for P. So for P, it is 2 squared plus y squared, which is -1 squared, plus z squared, which is 3 squared. That is for P. So the magnitude for P will be the square root of 2 squared is 4, 4 plus 1, 5, 5 plus 9 is 14. Now for Q, the magnitude is square root. For x squared for Q is 1 squared, plus y squared for Q is 4 squared, plus z squared for Q is -2 squared. Again, 1 squared is 1 plus 16, 17 plus 4 gives you 21. I hope I'm correct. 1 plus 16, 17 plus 4, 21. 4 plus 1, 5, 5 plus 9, that. Now, definition of the dot product. So -8 equals to the magnitude of P, which is √14, times the magnitude of Q, which is √21, then cos theta. So you can see cos theta is equal to -8 divided by √14 dot √21. Now let's get beta, which is the acute angle formed by the cos inverse of, ignore the negative, 8 over √14 dot √21. So let's find that beta and use beta to get our theta. So first, let's first find okay. Let me clear this. So I have 8 divided by into bracket square root of 14 close the bracket, times the square root of 21. Close the bracket and then close again. When you do that, and then we'll just get the cos inverse of 0.466 as 6. That will give us the acute angle beta, which is equals to, now, cos inverse, clear, cos inverse of 0, cos inverse of 0.466 as 6. Close the bracket. The acute angle is 62.19 degrees. Now to get the other angle, to get theta, we look for where cos is negative. So we need a unit circle. In a unit circle, on the acute side, all are positive. On the angle greater than 90, which is 180 minus our acute angle, it is sine positive, then tan positive here, then cos. So we only need to get our angles here or here for our theta. So our theta is first 180 minus our acute angle 62.19 degrees, which gives you what? Our next theta is in this third quadrant, which is 180 plus our acute angle 62.19. So all this will give us negative cos. So we have 180, so 180 minus 62.19. You can see that gives us 117.81 degrees. The other angle is when we have a plus. When we add, this gives us 242.19 degrees. So both this and this give us a negative cos. So our theta are either this or this, which is formed between these two particular vectors. So that is the angle between vector A, vector P, and Q. I hope that is clear. Our beta is here. Then here is 180 minus beta. And here is 180 plus beta, it is plus 180. And this place is 360 minus beta. So since cos is only negative in the second and the third quadrant, our two answers are this and that. And that is the end of revision 2, which is on dot and cross products.